Okay, so yeah, welcome one more time to the part 2 of this video. This is the question we are answering. In the previous part, we drew the front to the top view of the hexagonal prism. Now in this part, you want to draw the true shape of the truncated section, okay, and of the top of the prism. So true shape. First of all, we are going to draw a line that is, draw a line, so use line command. Now this line should go through all the common vertices, so points D, E, C, F, B, and A. Okay, now apart from the lines going through these vertices or these points, they should also be perpendicular to the line representing the plane, the cutting plane. Okay, so I'll just start my line from there. Okay, once I'm zooming into that, make sure I got the correct point. Okay, zoom out. Sorry, draw out your line. Your line should be 90. If we want the line to be 90 to the the cutting plane, the whole line will have to be 90 plus 30 degrees plane of angle of inclination of the plane. Okay, I'm zooming out just so I can have a longer line. Okay, so I'll move till I arrive at a point of 120. I'm currently at 119, 121. Moving gently till we get 120. All right. Okay, so just to be sure I got the right angle, let me try and measure the angle between my new line and the inclined plane. So angular, first line, second line, 90. So that's correct. That's correct. Now I will extend this line. I'll extend it, even though it's still at the same point. I'm going to essentially stretch it. Okay. No, I'm stretching in the wrong direction. Escape. I want to stretch in the top direction rather. Why am I stretching the top direction? Because I want to draw the true shape over there at the top. So I can enter value. Let me stretch by. Okay, I've stretched. I'm making sure I'm still at angle 130, 120. Then I click. Alright, so I'm going to repeat a similar thing. draw a similar line. Draw a similar line, points of intersection, then also out at an angle of 120. Okay. Repeat the same line. Once I see the end points, okay, that's the end point of the vertical line. Or once I see the let me zoom it in. Okay, intersection. Zoom out. Then I can draw my line out. Also at 120. One, two, two, 120. Okay. Then the very last one. Repeat line. Okay. Taking it from the end point. Also at 120. Now, instead of watching the angle, you can also hover your crosshairs over the previous line, which you drew at 120. Now, once you attempt to get as close as possible to drawing your 120 in your new line, you'll notice that the parallel symbol appears on the previous line. Okay, which means that the new line you're trying to draw will be parallel to the previous one. Okay, once I'm sure of that, I can left click to indicate the end of my line. Enter. Okay. Now, still on drawing the auxiliary view, we'll draw a line, new line that is parallel to the surface, of the truncated prism. Okay. In a sense, I want that line to be parallel to the red surface here, the red top inclined at 30. Okay, so specify first point. I want my point to be anywhere is convenient, anywhere convenient for you. Okay, I want to choose here, which is the midpoint of the last line I drew. Okay, now I'll take my crosshairs, hover it over the inclined line. Okay, you can see that my parallel symbol has appeared as I hover it over the line. So once that appears, I can move it away. Okay, then turn the line until I see the parallel symbol again. So parallel symbol appears. Parallel, okay. That is not appearing, but I know that my inclined line is at an angle of 30, just as the previous one. So I will move my crosshairs until I see angle 30. Okay, so I can click. All right. Now, let's do the labeling of our points. This very point here, okay, let's call that points D. Specify first point, it can be anywhere. Height 5, angle 0. Okay, so that's our new points D. Okay, let me still call it point D. Then the one in the corner, sorry, the one to the left, I'll call that place point A. Okay, take note, the points I've labeled only have single, vertices. Now the whole point, or the whole idea about this auxiliary view, okay, or auxiliary projection, is that whatever we are seeing here, we are rotating whatever we are seeing here, A, F, B, E, C, and D. We are rotating that whole surface, which in the front view is appearing as just a straight line. We are rotating that whole surface such that it will appear as the distorted hexagon that it is. Okay, so it means if we have this point where you can see my cursor, point EC, 2 points are coinciding, but once I rotate it through 180 degrees, the 2 points are going to lie along this line. Okay, same thing is happening for the line here. 2 points F and B are going to lie along this line. Okay, now what is the distance between those 2 points which I indicated right now? Now between point F and B, what's the distance? Look at the top view. What's the distance? The distance would be from here all the way to here. Okay, now what about between E and C? It's essentially the same distance. So we are going to use half that distance, okay, as radius to draw 2 circles or 2 sets of arcs. Okay, so let's do that. First of all, take the distance. Let's see the distance between B and C. It's still the across flats distance of the hexagon. So that distance is, if you can remember, the diameter of the circle was 50. Okay, to be on the safer side, let's just measure. Let's just take the measurement. Just take the measurement. It's not an angular one, it's a linear one. So distance between here and here is 50, like I said. Okay, change its layer. There's a dimension. Okay, so if the whole distance between F and B is 50, half will be 25. Okay, so we are going to use arc command. We are going to use arc or circle command. So use circle command, center and radius. Okay, stand at F and B, point F and B. This is D. This should have been A. It's disappeared. Okay, now this is F and B. F and B will fall along this line. So click the center, click the point of intersection of the 2 lines, and then indicate a radius of 25. Enter. Okay, or we can also use arcs. Okay, we can also use, so between F and B, one of this is going to be B and the other one is going to be F. So just call this use test command, single line. This point here is 5, 0. So this point here is, let me call it F, and the other one far at this point, I'll call it E. Sorry, B. Okay. I don't like the way my circle is intersecting so many points. So this time around, for E and C, I'll use arcs. I'll try arcs. So here, so this is supposed to be B, okay, and this is supposed to, this point here, the 0 point here is supposed to be A. Okay, so I'm going to try arcs this time around with the same radius 25. What is the 25? The 25 is the distance between this, the center, and then C, or between the center and then E. Okay, so we are going to draw the arc for points E and C on the auxiliary projection. So use the arc command. Here's our arc command. Don't use the 3-point arc, move straight to the kind of arc that starts with center. So let's use center, start, and end. Let's use this option. Center, start, end. Okay. All right. In this case, this is our center, this point of intersection here, the X or the cross. Then where do you want to, okay, what is showing here now is my radius. The highlighted part is my radius, highlighted in blue. So I'll enter my radius. It's actually 25. Okay, then I just have to indicate the start point of my arc. That looks like a start point. Okay, let me take it again. Take the whole process again. So cancel, go for arc, center, start and end. This is the center. So two things are highlighting here: the center of the perpendicular projection I did, and then also okay, this perpendicular. Zoom in. Okay, let me indicate my radius. This is 25. Now I want to, it assumes that you start from the AutoCAD things that you start your arc from the, let me say, from the right side. So first we started around this place, but now I want to start from around here. Okay, so enter my 25 again. Then you move anti-clockwise, you enter your next one. Okay, repeat arc, not midpoint but rather X, point of intersection. Then zoom out, enter your radius 25, enter, then again, oh, I have to repeat the arc command. Escape, arc command, center, start, end. So there is my center. I'll go anti-clockwise. So enter radius 25, enter. Then I'll go anti-clockwise in that direction. Okay. So this is going to be my C. This point here is going to be my C. Just labeling. This point here is going to be single line text. This point here is going to be my start point. Height is still 5, angle 0. And this point here is going to be my C. The one here is going to be my E. Okay, so we are done with our rotation. So you can see clearly using the arc is cleaner than using the circle, because we now have to use trim to clear all the mess that was created by using the circle. Okay, so what I'll do is you just remove the circle, select the circle and delete it, and then rather use the arc command, because I'm using that because it's neater. So center, start, end, center, start, end, center, start, end. Indicate your center. That's my center. Okay, I'll move in the clockwise direction. So start from the point on the right. Enter your 25. Then I go. I can stop here. Repeat the same thing. Repeat arc. This is the center. Zoom in to make sure you're at the right place. Now again we'll go in the anti-clockwise direction. So rather start from here. Enter 25. Hit enter. No, it's misbehaving again. I'll select arc again. Center, start, end. That's the center. Then I'll move in the anti-clockwise direction. So enter 25. Start, that goes on smoothly. Okay. Now I have all my points. I'll just have to join them with a polyline. Polyline instead of normal line. To join with polyline, you join the points of intersection. In order to see it well, you have to zoom in. Okay, and with this helps much better if you are using a mouse. I find my point of intersection, zoom in, click. Okay, make sure that you see the intersection. So there are so many points around here. Okay, midpoints, tangents. This one is tangent, that's not what you want. But I want the intersection of the line and the arc. So click that. Then the next point is here. Zoom in closely to see the exact points. Intersection. So I will choose, I'll left click that. Left click. Again, zoom in to see the exact intersection. Then click. Zoom in again to see the exact intersection. Then you click. Okay. Zoom in again at point A. Zoom in. Then you can close. Right click, enter. Okay, so we have that. We are going to have to we have all our outlines neatly. Let's try to hatch this. Let's try to hatch the cross section. Okay. Before we do that, let's apply layers. Actually, the outline of the cross section should be indicated. It is a visible line. Okay. Then all the other lines are construction lines. Now, if you attempt to dimension the hexagon, you will see that the shape is different. The shape is different from the one in the plan. Okay. The hexagon we have right now have some parts which are longer than others. That's what I meant by the hexagon is deformed. Let's take the dimensions of this hexagon. Dimension. Okay, let's take the linear dimension. Automatic dimension is not working. Okay, so for example, this intersection here, that's the first point. The second point, this intersection here. Okay, that dimension is in the x direction. Let me do another dimensioning. Okay, this seems to work fine. Okay, so now the distance. Okay, now you see here the length of one side of the polygon is 28.87, but when you come here, the length is 33.91. Okay. I'm going to try to trim the inside. Sorry, hatch the inside. Okay, so let's try the hatch command. I want us to use this. So I select that. Pick internal points. Okay. Now, the way it's appearing, it means I have to hatch several places. And let's try that. Hatch here. Hatch that place. Okay, hatch there. Click and click. Okay. Okay. So that's it. We have our hatching is complete. All right. So that's the second part. Let's label it. Let's label the part nicely. Here, single line. So this is the true shape of the truncated face. Sorry, it should be 5. Angle 0. So this is the true shape. Oops. True shape of the truncated face of the prism. Okay, once I'm done typing, I can click elsewhere and hit escape. I'm going to zoom out and drag my true shape. I want to drag my true shape from off the drawing, so I can place it here. I can place it on the top nicely. Anyway, that looks convenient. Okay. All right. Okay, so you have finished part 2. Thank you very much. See you in the next part.